Okay, so in this video we're going to talk about this shielding and deshielding effects in proton NMR. So in proton NMR, we are going to take these hydrogen nuclei, right? This is our hydrogen atoms nuclei, and there is an electron which is going around our nuclei, right? So what we are trying to do is we are going to send a magnetic radiation, and due to this magnetic radiation, our spinning direction will be changed and it again will be relaxed. So as a result we are going to take a signal, but the problem is there is an electron which is going around this our nucleus, right? So electron here, this is an electron, it is moving, which in basic physics this will generate a magnetic field. So this magnetic field will interfere our signal, right? So what we are actually observing is this magnetic field will interfere our signal. What we are actually observing is the difference between the original signal and this magnetic field of electrons, right? This difference is what we are observing as proton NMR graph, right? Now let's think like this. Assume this electron density, right? This electron density is higher, right? Electron density is higher, which means there are much stronger interactions, much more stronger effects on our original signals, which means this component, which our magnetic component, will higher. So our observing value is much more different than the original signal value. This case is called as shielding effect. Why? Because the electron density is shielded around our nuclei. It is much higher, the density is much higher, it is shielding around our nuclei, which means we are getting a huge difference from our observation than our original signal. But assume the opposite. Now our electron density is lower. Now there are much less magnetic interactions, right? So which means these compounds will be lower, which will lead us to the most similarly like original signal, which we will be observing, right? Our observation will be most likely the original signal. So this is called as deshielding. Why? Because the electron density is lower, which means there are no electrons to shield our nuclei, which we call as deshielding. So this is the basic theory of the shielding and deshielding. Let's apply this theory into an example. Okay, so let's take an example like this. Let's take CH3 COCOH, acetic. This is acetic acid. So there are two types of hydrogens in this molecule, right? These three are equal and this one is different, right? So let's denote this as A and this is P. So what happens is, look at these oxygens. These oxygens are higher electronegative atoms. So what is they are doing is they will pull out the electrons from their neighboring atoms. So from these two hydrogens, you must know which has the greater effect on this electron pulling. This hydrogen will have the greater effect because it is directly connecting to a oxygen. So this hydrogen's electron density will be much lower. Then what is it? Shielding or deshielding? It is deshielding, right? It is deshielding. How about these hydrogens? They are not directly connected to oxygen, so which means their electron density will not be much lower, which means they are shielding. They are shielding. So now let's think about our observation. Our observation is coming from our original signal, but not the actual original signal. It will deducted by this effect. In this case, in deshielding section, we have a lower effect, but in this case, in shielding effect, we have a higher effect. So from this, in this case we will have the low observation. Why? Here in this case in higher effect we will have the higher effect, so this observation component will be lesser than this. In this case this is lower, so it means the smaller value will be deducted from our original signal, which is our observation will be relatively higher than this one. So if I plot these two signals, there are two signals, you can identify which one is the shielded one, which one is the deshielded one, right? We know in shielded one, right, which shielded one, there is a higher effects. There are higher effects, which means the lower observation. So this is the shielded one, and this is the deshielded one. So if we talk, this is the higher we normally call it this as, this is downfield, this is upfield, and normally this other important factor is this observation. We are getting observation as a frequency, right? We are getting the observation as a frequency. So you must know that this is the deshielded one. This is the deshielded one, which means the lesser effects, which means our observation is much more equal to the signal, which means the higher frequency. Here in this case, the shielded one, higher effects, it will be much lower than our original signal. Here higher effect, much more higher value will be deducted from our original signal, so which means the lower signal, lower frequency. So this is the basic concepts in shielding and deshielding effects. So now here we have identified which is the deshielded one and which is the shielded one. So this signal is based on the B hydrogen, and this signal is based on the A hydrogen. So this is a simple example. We will talk about more example in next videos. I hope you get the theory and concept in the shielding and deshielding effects.